question from the paper 2020, right? In this, they said three similar coils, when connected in star across a 400 volt, means the line voltage is given 400 volt, 50 hertz means frequency is hertz, takes a line current, means IL is given current of 10 ampere, right? 10 ampere at an angle of 6.86 degree, right? Determine the circuit constant. Circuit constant means we need to calculate either it would be RL, RC or RLC. So how can we get? By the formula of VPH is equal to IPH multiplied by ZPH. Mainly we need to calculate ZPH value, right? Then only we'll get able to get RL, RC or RLC. So VPH we don't know, as it's a star connection. We are having the relation is PL is equal to root 3 VPH. PL is 400 divided by 3, then you will get VPH, right? So we can substitute the value of VPH is 400 divided by root 3 is equal to IPH, and IL in the star connection is always same. So we can directly write down 10 angle 66.86 multiplied by ZPH, right? So again 400 divided by root 3 divided by 10 angle 66.86, you will get it as ZPH. Okay. First of all, tell me any doubt up to here? So basically 400 by root how much? 30 angle 0 divided by 10 angle minus 66.86, right? If I'll solve it further, then that would be 23 angle, sorry, it's plus, angle would be minus 66.86, right? Okay, now it is in which form? Polar form, and we need to convert it in which form? Rectangular form. Just to get it know that whether it's the combination of RL, RC or RLC. Okay, so this is the polar form, 23 angle minus 66.86. Then if we'll solve it, you will get that pH is equal to 9.039 minus J 21.150. Okay, can you convert from the polar form to the rectangular form? Now if I'll compare it with the standard equation, as I told you, if R is there and L is there, then we'll use R plus JXL, and if minus is there, then we'll use R minus JXC. So we can say it's an R minus JXC. So from this we'll get simple, the R value is how much? 9.039, right? And XC value is how much? XC we got it as 21.150. X is 1 by omega C. Omega is equal to 2 pi f. So now we know the value of XC. Can we get the value of C? Hmm? Okay. So from there you will get circuit constants, means we get R and C. Next they are asking the power factor. As you know, power factor is denoted by the term cos phi. Cos phi. Phi is the angle between voltage and current, that is 10 degree. Because voltage angle is 0 degree and current angle is, sorry, current angle is 66.86. So we'll get cos of 66.86, right? Voltage is 0 degrees, so 0 degrees here, 66.86 is like this. So angle between voltage and current is this one. After solving it, we'll get the power factor, correct? Next one is the complex power drawn from the source. Basically, complex power means the apparent power, that is denoted by S, is equal to P plus JQ. Complex power will always write down in the rectangular form. So ultimately we need to calculate P. P is equal to how much? 3 VPH IPH cos phi. Q is equal to how much? 3 VPH IPH sin phi. So 3 already we know, VPH already we know, IPH already we know, cos phi we already know. Again 3 VPH IPH we already know. If we know the value of cos phi, can we get the value for sin phi? Hmm? By the formula of cos square phi plus sin square phi is equal to 1. So we can substitute the value, then we'll get the complex power. Okay.